At this point in the class, we've got quite a bit of scaffolding for us to start writing code in Python. So what do we know? We know variables and variable assignments. We know data types, ints, long ints, floats, strings. We know functions. We can abstract out and call functions that perform certain functionalities. We know how to import functions, modulos, that are given to us either by other users or by Python itself. We have a looping construct, a while loop, that allows us to repeatedly perform the same operation over and over and again. And we have conditionals, which is that we evaluate certain bits of code only when certain conditions hold within the if, elif, else ladders. And so what we're going to do now is we're going to sort of put aside some of the programming constructs and start talking about some of the data constructs or data structures. And then eventually we're going to put everything back together because, of course, data structures without code doesn't help and code without data structures doesn't help. So we're going to talk about our first data structure today, which are called lists. And eventually we're going to talk about more complex data structures both here in 206A and eventually in 206B if you join me for that course as well. So let's start with something that we're already familiar with, variable assignments. So what have I done here? I've assigned 7 variables called moons1, moons2 to moons7, and I've assigned them what? The string, because you have the quotes there, of the names of the 7 moons of Jupiter. So Io, Europa, and so on and so forth. Okay? And nothing wrong with this, perfectly fine way to represent these 7 moons. But there's something a little clumsy, if you will, about this, which is I need these 7 different variables, and what if Jupiter had like 27 moons and I'd have 27 variables? And these are clearly related to each other. These are clearly sort of one thing, which are all of the names of Jupiter. And what lists allow us to do, and generally speaking what data structures allow us to do, is to combine lots of related information into one structure, a data structure. And that's exactly what lists allow us to do. Lists are a built-in data structure inside of Python. We'll eventually be able to build our own data structures and objects and classes, which we'll be doing in the later part of this course and picking up in 206B. But for now, what a list is a collection of data. In our case, they're just strings, but they could be numbers, they could be booleans, they could be anything, that are bundled up together into a single variable. So this one line of code here is defining a single variable called moons. So there's my variable, there's my assignment operator, and on the right now is something that looks a little new. It's got an open square bracket and a closed square bracket, which tells Python that this is a list, and inside of the list are comma delimited strings. Again, you can put anything you want in here. We'll see more examples in a little bit. So this is defining a list where I've taken 7 strings, I've bundled them up, and now I have a single variable that has 7 parts to it, if you will. Okay, so a list is created or initialized, open square bracket, close square bracket, comma delimited, put whatever you want in there, and it bundles it up into this one variable over here. Now, it may not be immediately obvious why this is useful or why you want to do this. We'll see lots of examples of why it's nice to bundle up data like this and then how to operate on it. But for now, let's talk a little bit about these lists, because obviously it's not enough just to create them. We want to be able to do things with them. So you can access elements of the list like this and like this right here. So let's look at this statement right here first of all, this first print statement. So this is familiar, mostly familiar. Print, Jupiter's first moon is, space, quote, plus. What is that plus? Well, if that's a string, that must be string concatenation. I'll skip over this for a minute, plus, period. So what am I doing? I want to say Jupiter's first moon is, and then I want to reach into that list right there and grab the first string, which is the first moon of Jupiter, Io. And the way I access that is to use the variable name moons, notice that variable name right there, square bracket, same square brackets that you use to define it, and inside of there, right there, is an index. It is telling me which element of the list do I want access to, and it is indexed on 0. And this will be a source of untold number of bugs and annoyances for you that lists in Python and most modern programming languages, we start counting at 0. So that's the 0th element. the element in the 1 position, 2, 3, 4, 5, 6. An element with 7 lists has elements in position 0 through 6. And so be careful with that. I'll remind you that over the next few weeks. So I can access an element of a list by simply saying, what's the name of the list and which of the elements do you want? Which door is it behind? Yeah. So this will print the 0th element. This will print the first element, which of course is that string Europa. And notice that this is a string, that's a string, the periods, and this is a string by definition because I've defined them as strings. And if it wasn't, we know what you have to do. You have to convert it to a string in order to do string concatenation. So when I run this code, it sort of does what you expect. It reaches into the moons list, it extracts out the 0th element, and it shoves it into the print statement. So notice that this isn't that different than if I had defined 7 variables called moons 0, moons 1, moons 2, moons 3, moons 4, up to moons 6. And I defined them to be Io, Europa, and so on and so forth. And then here, instead of the square brackets, I just said moon 0, referencing that previous variable. This is a variable. It's just that there's a level of indirection here. You have to say, what's the list? And then, which element do I want? Okay, so it acts, each element of this list acts in the same way as a regular variable. It's just stored differently and referenced differently. Okay, good. So in addition to, say, printing the 0th element or the first element or the 6th element, the last element in the list, I can just print the whole list. So if I just say print moons, it will return the entire list. So this data structure, a list, you can interact with it in 2 ways. In its entirety, just moons, or tapping into one element at a time. Okay, and you'll be able to tap into more than one element, and I'll show you examples of that in a little bit. Okay, now, this was a list of strings. As I said earlier, lists can have anything you want in them. So here's another list that has numbers in them. So numbers is equal to, again, open square bracket, close square bracket, comma delimited, 3, 7, 42, 19, 26. And then if I say print numbers, it prints the entire list. If I want to access that number, it's number sub 0, 1, 2, 3, 4. So again, remember, lists are indexed on 0 to n minus 1, where n is the total number of elements in the list. Good. A list can be empty. You can say nothing, variable name, is equal to square bracket. That's an empty list. Not clear what you want to do with that, but we'll see some examples where every once in a while we want to have an empty list. And then when I say print nothing, it'll just print an empty list. Okay, so a list is a data structure that contains 0 or more elements. In these 2 cases, all the elements have been the same type, integers, strings. You can intermix them. So I could have had a list with 2 numbers, 2 strings, a floating point, and a Boolean. Anything you want in there, comma delimited, shove it in there. You're perfectly fine. It's a way of storing information that is presumably related to each other. Okay? And again, we're going to see examples of exactly why you want to do this in a little bit. All right, so now we know how to create a list. Open square bracket, close square bracket, comma delimited, shove whatever data you want in there. We know how to access them. The 0th element, the first element, the second element, using the square bracket index or reference notation. Now, you can also change lists. They are immutable, the same way you can change a variable. If I assign x to be 5, I can reassign x to be 7, or I can reassign x to be the string Horton, Lorax, or Maisie, 3 characters, of course, from Dr. Seuss. So here I'm defining a new list. It has 3 elements in it, the 0th, the first, the second, square bracket, comma delimited. Good? Now, we know how to access, if I wanted to print that, I would have said, please print for me characters, sub, I'll use the word sub to be square bracket, it's a little bit more concise, so sub 1, index into 1, but I can also change it. So here, what am I doing? I've got now characters sub 1, not on the right-hand side of an assignment operator or a print statement, but on the left-hand side. What is it doing on the left-hand side? It's an assignment operator. In the same way if I had said x is equal to this. So character sub 1 now reaches into that position right there and says, please reassign for me Lorax to thing 1. And now, when I print characters, what do I get? Well, that position hasn't changed, Horton. Maisie hasn't changed, but Lorax has changed to thing 1. And so now my list contains Horton, thing 1, and Maisie. So not only can I create a list, not only can I access it, I can modify individual elements in exactly the way you would expect it to. Character square bracket, number square bracket is, think of it as just a variable. You're just accessing the variable that is embedded within this list. Now, inside of this bracket can also be an expression that evaluates to a number. So if I say characters of 5 times 2 minus 9, which of course is 1, is equal to Lorax, then I'm going to go back and grab character sub 1, and I'm going to replace thing 1 with Lorax. So this can be an expression. It can be anything we want as long as it evaluates to a number between 0 and the length of the list minus 1. So 0, 1, 2 for a list that has 3 elements. Now, this can also be, what's in here can be a variable, right? So if I say x is equal to 1, and then I say characters sub x is equal to Mason, well then that simply evaluates to 1, and then I'm going to replace this position now. We went from Lorax to thing 1, back to Lorax, and then over to Mason. Okay, now let's just do another example to make sure we understand this. And I like this example because now you see the 2 pieces that we've done. I'm defining a list with 4 elements in it, index again on 0, 1, 2, 3. These have the numbers, of course, 2, 4, 8, 12, comma delimited. I can access, let's look at the right-hand side of this operator, the second and third element, that is in position 2 and position 3, just using the square bracket notation. So some numbers sub 2 is equal to 8, some number sub 3 is equal to 12. I have an expression on the right-hand side of this assignment operator. What do? Evaluate it, right? That's 8, that's 12, sum them up please for me, I have 20. Take that 20 and do what with it? Assign it to a new variable, which is the 0th element of the list. I could have said x is equal to this, and I would have said, okay, x is equal to 20, no problem. But now what I'm doing is I'm taking that result of the expression, and I'm shoving it into the 0th element of the list. And so when I say print numbers, I get 20, and then of course 4, 8, and 12 haven't changed because I haven't modified them. So the elements of a list can be used as variables in an expression, in a print statement, in a call to a function, and they can be reassigned on the left-hand side of an operator as well. So they really, in many ways, again, just act like variables. It's just that the way you refer to the variables is a little bit different. You just have that little square bracket in there. Okay. One of the things you have to be very careful about with lists is that you don't try to access an element that doesn't exist. So for example, if I say, please print for me some numbers sub 4, let's see, 0, 1, 2, 3, there is no some number sub 4, so that will lead to an error. You can, and obviously if you try to index a negative number or a floating point number, you can only index on the integer starting from 0 to the length of a list minus 1. And so the question you want to ask yourself is, well, how do I know how long a list is? Well, how will I know? And of course, Python will tell you. So there's a built-in command called len, for length, of course, and it will tell you that the length of this list is 4. Again, be really careful here. We're counting starting at 0. So when I tell you the length is 4, you get to use 0, 1, 2, 3. 4 minus 1 is the last index into the list. And that will allow you to always, that len operator will be really useful because it'll always tell you how long a list is, and it'll tell you that you can always go from 0 to that number minus 1. All right, that's the basics of the list. It's essentially a data structure for combining information that you may want to have in a single variable. What are the situations you want to do that? We're going to see lots of examples of that. Right now, let me just explain the underlying infrastructure, and you'll see why it's useful to be able to bundle up information. And then what we're going to do is I'm going to show you how the various programming constructs, in particular looping constructs, interplay with lists very nicely. And that will also allow us to introduce the for loop that I've been promising, which is a different looping structure from the while loop. All right, let's pick it up in a little bit.